All right, future doctors and engineers, welcome, buckle up, because we're about to do a super fast, supercharged revision of one of the most critical chapters for your exams, motion in a plane. Let's get right into it.
So let's give your NEET and JEE prep a serious boost. And hey, if you want more explainers just like this one, don't forget to subscribe.
So be honest, does motion in a plane give you a little bit of tension? You see those questions and your head starts spinning? Well, don't you worry. In the next 5 minutes, I promise we are going to make every single important concept crystal clear. For real.
Okay, so here's our game plan. First up, we'll nail the basics, scalars and vectors. Then we'll play around with vectors, adding and resolving them. After that, it's the big one, a full postmortem of projectile motion. Then we'll decode uniform circular motion and wrap it all up with a quick-fire final revision. Ready? Let's do this.
All right, first things first. We got to build a solid foundation, right? Because trust me, every complex topic in this chapter starts right here.
So let's start with the most basic question of all. What's the real difference between a scalar and a vector? I mean, why do we even study them separately?
It's actually super simple. Look, a scalar quantity, it's all about the magnitude. That's it, just the value, like 5 kilograms of mass or a distance of 10 kilometers. Simple stuff. But a vector, now that's where it gets interesting. With a vector, you have the magnitude, plus you absolutely need a direction. For example, a 10-Newton force, but in which direction? Or a velocity of 20 meters per second, headed north. So the one word to remember? Direction. That's the whole game.
Okay, so now that we know what vectors are, let's have some fun with them. Seriously, learning how to add them and break them apart, that's the real key to unlocking this entire chapter. So, think about it. If you've got two forces, or maybe two velocities, acting on a single object, how do you figure out their total effect? Their resultant.
The first method is the triangle law, and it's so intuitive you'll get it instantly. Just take one vector, let's say vector A, and place the tail of the second vector, B, at its head. Now, just connect the tail of A to the head of B. That third side you just drew, that's it. That's your resultant vector R. It's a simple head-to-tail connection.
And the other method? That's the parallelogram law. For this one, you join both vectors, A and B, tail to tail. Then, you just complete the parallelogram using these two vectors as adjacent sides. The diagonal that starts from that same common origin, that's your resultant. And guess what? Both laws give you the exact same answer.
Now, this next question is super important. Why do we even bother breaking a vector down into its components? What's the point? What's the benefit?
Oh, the benefit is absolutely massive. See, resolving a vector turns one complicated 2D problem into two super simple 1D problems. We just break the vector down into its x component, which is a cos theta, and its y component, a sine theta. And now you can solve the motion on the x-axis separately and the motion on the y-axis separately. It makes your life so much easier.
Okay, so now let's see how this awesome concept of vector resolution leads us straight to the star of the show, the main event of this chapter, projectile motion. I'm telling you, both NEET and JEE love to ask direct questions from this topic. Just imagine this. You throw a ball up in the air. That path it follows, what shape is it? Is it a straight line? A circle? What do you think?
The answer is a parabola. And the reason is actually pretty simple. Think about it. In the horizontal direction, there's no force, right? So the velocity is constant. But in the vertical direction, gravity is pulling down, giving it constant acceleration. It's the combination of these two independent motions that gives us that classic parabolic path. The one with the equation that looks like y equals ax minus bx squared. And this slide right here, this is your secret weapon. These three formulas, time of flight, maximum height, and horizontal range, you have to know them by heart. No excuses. Almost all of the numericals are solved by directly applying these. So take a screenshot of this, write it down, do whatever you need to do, but memorize them.
All right, let's move on to our next topic, uniform circular motion. Now, there's a really interesting, kind of confusing concept here. The speed stays constant, but the body is always accelerating. Sounds weird, right? Let's clear that confusion up right now.
This is the classic trick question that stumps a lot of people. If a car is going around a circular track at a constant speed of, say, 60 kilometers per hour, where does the acceleration come from?
It's because You guessed it, velocity is a vector. Even though the speed, the magnitude, is constant, the particle is changing its direction at every single moment. And anytime the velocity changes, even just the direction, you have acceleration. This acceleration is always pointed towards the center of the circle, which is why we call it centripetal acceleration, which literally means center-seeking. And to find the magnitude of this centripetal acceleration, the formula is simple. AC equals v squared divided by r, where v is the particle's speed and r is the radius of the circle. This is another one of those formulas that is absolutely critical for your exams. Okay, let's quickly revise everything we've just covered. These are the key points, the absolute must-remembers that you need to take with you into the exam hall. So let's summarize this fast. Number 1, always remember resolving vectors is your most powerful tool. Number 2, think of projectile motion as 2 separate 1D problems. And hey, they will ask you this directly. When is the range maximum? The answer is 45 degrees. And finally, in uniform circular motion, even with constant speed, the acceleration is always towards the center. That's it. You remember these? You're in great shape. And just to leave you with something to think about, so far we've completely ignored air resistance. But what if it were there? Why do you think, in real life, a cricket ball's path isn't a perfect parabola? The answer to that, well, that's next-level physics.
And that is a wrap on our super quick revision of motion in a plane. I really hope all those concepts are much clearer now. For more of these rank-boosting explainers, you know what to do. Make sure you hit that like button and subscribe. Keep up the hard work, and I'll see you in the next one.